The opportunity was given to us to sit down and speak with you folks today just a little bit about some of the experiences we've had and some of the things we can share as a cloud provider in terms of helping you folks know what you should look out for when you go out and evaluate clouds on your own. Now, Terramark's not exactly a household name, so the question might come up of kind of, well, who's this blonde guy on stage or brown-haired guy on stage telling me what to buy for cloud? So just tell you a little bit about Terramark and why we're qualified to speak about what we do here. So we've launched our enterprise cloud platform probably about, at this point, 2.5 years ago. So that was, for anyone who was at VMworld 2008, the word cloud didn't even exist. So as far as clouds go, we're kind of the grandfather of the industry, or one of. And a lot of people think, well, kind of clouds is, again, you look around, it seems like a new thing. Everyone's all of a sudden talking about it. But if you have participated in an online marketing campaign from one of the largest fast food companies in the country, you've used our cloud. If you bought a car last year and got a government refund, you've used our cloud. If you've filed your taxes online, there's an 85% chance that you used our cloud. And if you've sent mail and bought postage online, you've used our cloud. So the cloud is actually very alive and out there today, and a lot of people are already using it and spending big dollars on it. So I just want to be clear that there's some potential here, and it's not just a new technology. We're speaking from experience, not just kind of what you should hypothetically look for. So that all being said, the first thing 85% and 90% of the people downstairs are going to tell you about when you go and ask about cloud is that you don't have to worry about all the stuff you've spent the rest of your career worrying about anymore because it's the cloud now. So everyone's going to tell you, well, we'll take care of infrastructure. The beauty of cloud is that you don't have to worry about it anymore. Now, that's an interesting statement and one that we completely disagree with, and the one that I'm going to tell you should disagree with as well. Cloud will make it easier and make it so you don't have to actually interact with your infrastructure every day, but it doesn't mean you shouldn't care about it anymore. There's a reason cloud providers don't want to tell you what's behind the curtain, and that's because usually it's very messy. So what you actually want to do is deep behind it, is to take a deep walk and look behind it. And the easiest way to realize why this is important is go home when you're done, Google, Bing, Twitter search, whatever you feel like doing, cloud outage. And look at the big branded cloud outages that have happened over the last 2 years. There's no shortage of them. You'll find them. And almost, I don't want to say 100% just because I can't authoritatively, almost every single one of them has nothing to do with cloud software. It has nothing to do with anything that's trendy or hypervisors or anything like that. They are old-fashioned data center and infrastructure problems that IT people solved 4 years ago. They are telephone poles that fell down into the side of a building and took out a PDU. They are power spikes that took out the infrastructure. They are fires. They are water incidents. They're things like this. They're the stuff that anyone who is practicing good enterprise-level corporate IT over the last 15 years already solved or built a resiliency plan around. And yet these folks who were building clouds and buying clouds got caught up in because they suddenly believed that they didn't have to care about it. So if nothing else, take away the message of, if someone's telling you that you don't care what's in their cloud, then you should look for a different provider. So now, even more importantly, this is a mixed audience, so it doesn't go over as well, but even more importantly is what are the things you have to worry about if you actually do things like make money on your cloud. Because a lot of folks say, cloud providers, I'm a startup, I'm in my basement, I'm in my garage, if I'm down for a half hour, it doesn't matter. However, most of the folks in this room are actually in the situation where you have real businesses running on your cloud or running on your infrastructure, so you actually have to care about it. And you have things like regulators to worry about. And I don't know if anyone in this room feels the same way, but I'd be curious if there's anyone in this country who, given the current political climate and financial climate, feels that the business they're in will be less regulated 5 years from now, as opposed to what it is today. So regulators are something that we have to live with. They're only going to get more into our day-to-day life, and they're going to want to know what's going on in your environment. You need to be able to build an infrastructure that's going to allow you to function and thrive in that regulatory environment. Same thing, we have security concerns. Everybody knows when you say cloud, the conversation comes up security. Even with our inside our company, we joke that we don't have cloud conversations, we have security conversations that lead to cloud orders. And the reason is that everybody who talks about cloud wants to know about security, and you have to meet with your policies. You know, anyone who's worked in IT knows you have the most important IT asset in the company, which is the CEO's mailbox, because when it goes down, so do you. So we have to worry about that. you have to deal with legacy devices. Again, not everybody's in a situation where you have the ability to just say, well, I'm building this from scratch and I can write my single-purpose, homogeneous application that's going to run in an envelope so I can put the whole thing in the cloud. Most of you have legacy mainframes, mid-range systems, big databases, serious investment in hardware and infrastructure that you need to be able to make sure it's going to work in the cloud. No one CFO is going to be okay with the fact that you said, hey, well, I can pay by the hour now, so we're going to throw away the last 10 years of IT investment. I just need you to give me a credit card number. It's frankly not going to work. And most cloud providers are not built to handle that. You probably have private networks, and then most importantly, at the end of the day, like I said earlier, you're making money off your cloud. So you need to be able to know that if the thing stays up, you make money. If the thing goes down, it costs you money. The reason these things matter is, and this is sacrilege to say in this building and where we are, but everybody is a cloud provider today. I mean, go to the Pavilion Hall and find me a booth that doesn't have the word cloud on it. You know, I'll give you $10 if you can. Everybody in the world is a cloud provider, from folks like us who came out of the data center world, to folks who sold books for the last 10 years of their life, to folks who write software, to everybody. Everybody and their grandmother is in the cloud business, and a lot of them have no business being in the infrastructure business. And a big part of determining what you have to do and what you're going to do when you're a cloud provider is making sure you can separate the wheat from the chaff and understand what's going on behind the marketing message. So what we're going to talk about today are a couple key areas that we think that are actually kind of very concrete that you need to look at when you're making your decision. So I'll give you all the reasons why, and now I'm going to tell you what. So the first one is what we commonly refer to as the noisy neighbor problem or noisy neighbor situation. Now, just to be clear, we're going to talk about two types of clouds here today, two kind of fundamental concepts in architecture when you're building a cloud. I'm really not espousing either one. They both have benefits and they both have drawbacks. And the message that I'm going to try to get to you, if nothing else, leave with the fact is that you need to know which one you're going into, so that way you can make an educated decision based on your application, security, and business requirements as to what you're going on. In fact, for a case in point, Terramark offers a cloud product in both of these, and many of our customers buy both. There's different price points and different responsibilities. So the first one is the commodity public cloud. This is the one that everybody has heard about. Everyone's getting the noise. If you Google cloud, they're the number 1, 2, 3, and 4 provider. It's the people who are giving away free stuffed clouds in their booths, and everyone has a cloud on it. This is, it's the lion's share of the cloud world. It's what's getting all the press. Typically, it's a single shared network, so it's flat. All your network segmentation and all your security happens at a software level. So you're sitting on one big network, and everything is happening at a hypervisor level. Typically, there's no ways for you to actually access the cloud other than the public network or some sort of higher level of security that's riding over the public network, so VPNs, things like that. You have to share your resources, so you have potential for I can't remember the word, but you have the provider can oversubscribe their resources because of the fact that you are dealing in a public resource pool where it's a balancing of load and your resources are not guaranteed to you. Same along that thought, it's a first come, first serve. The only guarantee you have that the computing you need is going to be available is the fact that the sales guy from the provider told you it would be. There's no technical guarantee that those resources will be there when you need them. And finally, the security, because it is massive, it is public, it's very communal. It's what's good for the one is good for the many. So what happens is that the thought is that if the security is good enough for the cloud provider, then it'll be good enough for you. Now, I don't know if anyone here is in the banking or healthcare business, but I could find you quite a few FDIC auditors who will tell you that that's not exactly what they would consider appropriate for the U.S. banking industry or the U.S. healthcare industry or any one of a bunch of other industries. The other side of the world is the private cloud, and typically what differentiates a private cloud are some of these things. First of all, you tend to see the ability to share off private networks. So you can use VLAN segmentation or some other security context where you can put your resources into your segment. You can integrate those legacy networks. So if you have MPLS networks, if you have legacy Metro E, ATM, whatever it may be, you can plug that into the cloud so that way you have a cloud that isn't restricted to just working on the public world. Those compute resources are guaranteed. So either through some sort of contextual technology or underlying hypervisor technology, those resources are guaranteed to be available to you, and you can actually point to software code and infrastructure management that shows you that they will be there available when you need them, not just because someone said they would be, which leads right into the guaranteed availability. And then finally, and you'll see this is a theme a lot for us, you have the ability to individualize and privatize your security unique to your own requirements so that you can dictate the requirements. You can dictate the security policies that are going to meet the requirements of your individual business. So the next thing we're going to talk about is the next two architectures are clustered hypervisors versus non-clustered hypervisors. Disclaimer for this is that, for those of you who don't know, Terramark is partially owned by VMware, and they are a big opponent big fans of the clustered architecture, so that's just my little 2-cent disclaimer, but we'll talk about both. So the vast majority of the public clouds out there are in a non-clustered environment. So if you think about it, all clouds at the end of the day are big piles of servers, right? They're aluminum and copper, their servers are sitting in a data center, no different than what's in data centers today. It's just a software architecture. In a non-clustered environment, those servers are not connected to each other in any other way than the network. So there's no clustering at the hypervisor level. So if you take that big pile of servers and you put your app on it and it's running up in the cloud and it's sitting on an individual server in a data center somewhere, in a non-clustered world, what happens is eventually that server dies. They all do. Every server dies. Doesn't matter if it's on the cloud or not. Servers break. It's what happens. In a non-clustered world, when that server dies, your application's out of business. You go home. Well, in reality, what you do is you pull a backup or you pull an image off of the object store. You make a request to your cloud provider to spin up an additional instance. You wait for it to be spun up. You hope it's available to be spun up. You reload your image, you reboot the box, you reconfigure everything, and then eventually, anywhere from a few minutes, if you're really good, to a few hours or days if you're not, your application is back up and running. Let's combine that with a clustered environment. So clustered environment, same pile of servers, same big pile of them sitting in a data center, except at this point, instead of just being connected at the network level, they're also connected at the hypervisor level. So the hypervisor is communicating with each other throughout the environment. Excuse me. Same application sitting there. Same server dies. It happens. Like I said, it does clustered, non-clustered servers die either way. It doesn't matter. What happens in a clustered environment is this time, instead of you having to do anything, the underlying hypervisor architecture is smart enough to realize that the box died. And sometimes, in our case, and if you get lucky with VMware using predictive failure, sometimes the hypervisor's smart enough to know it failed even before it does, and it avoids the problem altogether. What happens this time is your app is seamlessly moved to another box. You don't even know what happened. At most, you take a reboot, and a lot of times you don't even take that, and you continue to be up and running. So again, subtle differences. Neither one is better than the other, but if you're talking about an application that has zero tolerance for downtime, you want to be in a clustered environment. If you're talking an application where one web server is the same as the other 450, then maybe non-clustered is better for you. There's obviously price differences. The other advantage you get on a clustered environment is that it makes the environment more flexible for maintenance. So you don't have to be as subject to issues when your provider enters into a maintenance window, because the provider, someone like us, has the ability to move images around seamless to you, which then allows us to offer better uptime. So you will typically see higher resiliency, better SLAs, and better balancing of load in clustered clouds than in non-clustered clouds. The next kind of big area you need to look at and dig under the covers is the actual infrastructure. So we talked about the architecture. The next thing you want to talk about is the infrastructure. And again, this is probably the biggest area where people will tell you that it doesn't matter. So all the cloud providers out there will tell you, some of them are proud of the fact that their servers are made with Velcro. We argue that's a little different, and our marketing guy puts this up here, but I think it's a great example. If you were, a lot of you flew here for the show, a lot of you flew here. If you were going to get on a plane and you saw that the plane had vintage, 1942 Soviet-made Tupolev engines hanging off the wing with smoke coming at them, you'd probably be a little nervous. And when you went to the pilot and asked him about the engines, and he told you, well, don't worry about them. They fail all the time, but we got 20 of them on the plane. So you'll be good. Don't worry about it. I'm going to tell you, you're probably not going to want to get on that flight. The flip side is also true. If you go to get on that plane and there's one giant brand new GE Rolls-Royce SAS 70, whatever it is, never fails, and the pilot goes, well, it's got 11 nines uptime, but there's only one. You're probably also not going to be happy about getting on that plane. So it's like anything else, that you have to strike a balance of what you want to do between your infrastructure reliability and redundancy. So what you want to look at the very most, and we're biased here, is you want to look at the physical infrastructure. As I mentioned earlier, almost all the cloud outages have been infrastructure engineering, MEP-related issues that have been solved years ago. You want to look at the data center your servers are in. Are they in a Tier 3 or Tier 4 data center that's hardened against wind, earthquake, hurricane, tornado, flood, power outages, and all that stuff? Or are they in a server closet that used to be in the mall in suburban Dallas? These are two types of things. You want to know where those servers are going to be and what's going to happen when the power goes down. Because, yes, we have a lot better power infrastructure in our country than anywhere else, but it still goes down. Everyone's had a power outage at some point in their life. You want to make sure that those boxes are going to go up. You want to make sure that when the wind comes, the rain comes, your servers are going to stay up. The next is network infrastructure and connectivity. Again, there are a lot of cloud providers out there who pride themselves on doing everything on the cheap, and we have flat switches and we have all that. Well, as anyone knows, the network is the lifeblood of the environment. When the network goes down, it doesn't matter how great your hypervisor is. So you want to make sure you're investing in the network. You want to make sure that not only is it made of quality gear from providers that you're comfortable with and you know and that there's support behind, but it's also architected the same way. In order to cut costs, a lot of people have single-threaded cloud architectures. Again, there's one switch, one router, one firewall, and plugged into one server because the thought is if the server dies, it can just go elsewhere. Well, that doesn't always work. So you want to actually look for a provider that has a multi-tiered connected architecture where you have failover and hot between all the environments. And you want to look at capacity. A lot of times, especially to cut costs, the cloud providers out there are buying the cheapest available bandwidth. So they're going to a bunch of providers, who I won't mention by name, who sell bandwidth for $3 to $5 a gig. And yeah, well, it takes an extra 20 milliseconds to get where it's going, but who really cares? I would argue that you should. You want to make sure that your bandwidth, it's not only a matter of the quality of your infrastructure, but it's the quality of your bandwidth. And you need to test these things. When you're looking at a cloud provider, ask them for a demo, put a little app up there, and see how the app responds. See if they do a trace route, do those things. Again, I'm not telling you anything you don't know. Anyone who's been in infrastructure, you would do this if you were building connectivity anywhere else, so there's no reason you shouldn't do it with the cloud. Servers. As I mentioned before, servers break. You can architect around them, and you should, but at the end of the day, the best way is to minimize the amount of failure. So I would argue that you want to care about the Velcro server versus the IBM or HP or Compaq or Dell or any one of the major manufacturers who are time proven and who know their boxes run. Things like mean time to repair and mean time between failure actually matter when you're talking about clouds that are running hundreds of thousands of servers. Because when you're running 100,000 boxes, a mean time to repair of 2 weeks means you're losing one every day. And you want to make sure that it's only one or half of one, not that they're going down every hour, because as much as we can architect around it, you don't want to introduce failure into the system. And the last thing we talk about is storage, and this is one that always personally amazes me. Most people in this room, maybe not if Steve Jobs had his way, but if you were going out and buying a laptop or a home computer or a server, you would look at the specs. You'd say, okay, how big, what kind of processor does it have, what kind of memory does it have, what kind of storage does it have, how big is it? You'd also look at the disk drive speed. Everybody, you're getting 7K drives, 10K drives, 15K drives, whatever it may be. Yet for some reason, the entire world feels that when they move to a cloud, they don't have to ask that question anymore. So the cloud, the same question that you would say fundamental to even making a personal decision for something that you're not going to use any more than looking at movies and surfing the web, for some reason the entire industry has deemed it's okay to forget about when you move your massive infrastructure onto the cloud. And if nothing else, you need to pay attention to things like the I/O and the performance of the storage, because I can tell you many, many horror stories of customers who have come to us after they thought they were going to save a fortune by moving to a cloud and then found that their application broke because they couldn't talk to the storage fast enough or the storage couldn't respond. So yeah, it was only 7 cents a gig and they could buy 10,000 gigs if they wanted, but it didn't matter because they couldn't access anything. So pay attention to storage. I alluded to it a bunch, and again, in the interest of time, I won't drive it home because it's hopefully the one thing that if you've already thought about a cloud, you've already thought about security. But a couple of things you want to look at specifically with security is you want to look at the actual fundamental architecture of the cloud. So you want to go to your cloud provider and you want to say, take me through, give me a one line, for lack of a better way to put it, show me a Visio of your cloud. Let me see what talks to what, where the firewalls sit, where the infrastructure sits, where the security is in place. And not only do you need to know about that, but as I mentioned earlier, try to pass a PCI audit without that information. It's just not going to happen. You also want to look at the physical security. You could architect the best security in the world, and if someone can walk into the data center unhindered and walk out with a drive array, well, your data is not going to be exactly secure as one. So does your data center have armed guards? Is it marked? Is it secure? Does it have a berm? Does it have physical fences? Can you park a car underneath it? These are the types of questions that you want to ask. And think about this. Most cloud providers out there won't even tell you what data center your equipment's in. You can't even know. They'll say it's in Northern Virginia somewhere. There's no less than 95 data centers in Northern Virginia. You're going to find out which one your cloud is in. You need to actually go in and ask these questions and talk about what's going on. Authentication, management, security model, these are important things. You want to make sure you can integrate your single sign-on, things like that. And then the important one here is lifecycle security services. The example I always use is you could build the best prison in the world, Supermax, all this good stuff. And I assure you that if you don't put guards in front of it and maintain it, eventually the prisoners will get out. So you need to make sure that the company you're picking from takes security seriously and investing in it as a company. They're not just the guys who built it and said, well, don't worry, there's a firewall there, you're good. Who's patching the firewall? Who's putting the IDS? Who's watching it? Who's responding when the alarm goes off at 3 o'clock in the morning? Who's taking a look at it when our friends in Korea have decided that you're a nice target for a DDoS attack? Who's the one who's going to be there when you take a look at that? And that's important stuff to look at. And then finally, compliance and audit. You want a partner who, when you get that letter from the FDIC, HIPAA, PCI, name a bit. I don't even know what business everybody in this room is in, but I'm sure you all have your various regulatory bodies. You want to make sure that the provider you're going with is actually going to give you real answers that you can answer your auditor with, as opposed to saying, well, I think they're in Northern Virginia, but I'm not really sure. You want to be able to answer those questions. And what I would suggest and what we do is you should ask your cloud provider to give you a tour of their cloud facility and show you where their stuff is and maybe walk through a fake audit with them. The next one, again, I spoke about this earlier, is interoperability. Very few of us have the luxury, and it would actually be very fun if you did, to build an application from scratch and have a business that is only doing one thing. We all have applications, we all have legacy networks, we all have legacy devices. Hell, we have a cloud provider, we have a cloud customer who's running an who's the vast majority of their business runs on an AS400, and they use everything else for the cloud, and they can't get rid of the AS400 for another 5 years, but they wanted to get the benefit of the cloud. All of you are going to have similar situations as you dig through your infrastructure and you look at stuff. So you want to make sure that your cloud provider and your cloud architecture you're going with can support these types of things. Can you extend your legacy network? Can you take the massive infrastructure you've bought from CA, Tivoli, BMC, whoever it is, that you've spent millions, if not tens of millions of dollars investing in portals and web management, can you extend that into the cloud? Or are you going to have to build new for your cloud? These are the types of things. The savings you will get on infrastructure from a cloud will be quickly outweighed by the cost you have building a second management system if it's not interoperable. You want to look at your security models. You want to look at all that stuff. And then the last one, and again, we're speaking at VMworld, and we're partially owned by VMware, so this is, again, a biased comment. But you want to look at the way you interact with it. So portals are great. We demo ours. You can come and see it, and we'd love to show it to you. But at the end of the day, it's APIs and standards that are going to get used. That's what people who access the cloud every day use. So you want to make sure your cloud provider is going to pick an API and a virtualization platform that you have flexibility with. Quite frankly, you want to make sure that you have the API and the standardization so that if you don't like the job that we're doing tomorrow, you can take it somewhere else. The vast majority of the cloud providers out there are pushing their own standards. So if you don't like the way you're working on a cloud, well, good luck finding someone else who can take an AMI image and load it up. You don't like we're working on the cloud, all you got to find is somewhere else who runs VMware or someone else who supports the vCloud initiative. So the horse we've chosen in this race is obviously vCloud. There's a few others out there. I'm sure Paul Moritz is giving a presentation across the hall, and he's going to have an aneurysm I say this, but even if you don't go with VMware, make sure you go with a standard that other people are using. You want to make sure that you can actually be able to move your cloud and be able to get that standardization. Next thing is usability, and again, our marketing guy put this slide there, and it's a good one, because I don't even know what that's from, that picture there, but I assure you don't want me anywhere near it without 6 months of training, because it looks very important and it looks very complicated. The cloud is the same way. If you take a cloud infrastructure that the only way you can access it is by this arcane command language that you need to read 42 pages of API documentation and download a certain plugin, and you got to get the guy who wears the Linux t-shirt and the camouflage shorts because he's the only one who knows how to operate the command language, and you got nothing from buying the cloud. You didn't get any of the promise of flexibility or scalability. The thing needs to be easy to use. It needs to pass the CIO test. Can your CIO create a server? Without an instruction manual. If you can, then it's probably good. At the same time, you want to make sure that those APIs there for your more power users are available. You want to be able to script things. You want to be able to check on things. You want to be able to do all that stuff. You want to make sure you can report on all that. Big area where clouds are falling down in the market is their reporting. No one can say when things are up and down. A lot of the public clouds out there, the only way you would know your application is actually down is when you went to use it and it was gone. So is there reporting, is there monitoring, is there management underneath that that's going to keep it up? Can I dictate the roles for my security? Most of us are large organizations. Some of the customers we have 30,000 people in their IT organization. I assure you that not all of them need to be full admins on the cloud, nor do you want them to be. So you need to be able to make sure that your individual users, Joe can read things, Sally can read and write things, Bob is a full admin, and none of them can touch the site in Europe because that's a whole different set of people. You need to make sure those types of things are in place. And then finally, how easy is it to buy? Because anyone who's bought a server in this world before in their experience knows that is not always the easiest question. You go down to HP and they're going to show you all these great things, and then when you say how you buy, you say, well, you got to call a vendor partner, and then he's going to call a buddy, and then you issue a PO, and then you go through a distributor, and 8 weeks later, sometime a server will show up, hopefully all in the same box, but if not, it'll definitely get there this week, we promise. You want to make sure that cloud's the same way. So you have all these people who are out there espousing these touch and click interfaces and just point and click and create a server, but by the way, it's a 4-week lead time process of contracts and things like that to get to it. So you want to figure out how easy is it to buy. And then finally, you want to look, but close to finally, you want to look at the folks who are running it these days. And this is, again, one of the biggest ones. So who are the guys and gals running the cloud? Do they know what they're doing, or is it a call center? When your lifeblood of your business application goes down, is your recourse that you go to a website, fill out a form, and really, really hope that the guy who gets it is going to call you back soon? Is it that you dial an 800 number and speak to a gentleman named Chip in an offshore call center who is going to ask you your name and company name and account number and go through 25 minutes of introduction before he even looks at your server, and then he's going to spend another 5 minutes asking you scripted questions to make sure you actually are using the cloud he's calling about? Or are you going to pick up the phone and call the guy who helps you implement your architecture, who checks it with you every day, who sends you your daily reports, and who knows how everything runs and knows where all the interactions are? Again, for some opportunities, for some of your business applications, the first may be appropriate. For others, I assure you the third is. You need to just ask the question. The other thing is, and then another one, and this is our marketing people put that in there, I don't necessarily agree with it, but you want to make sure that you can get your services, other things you need from your cloud provider. There is certainly some benefit to one-stop shopping. It's the reason Walmart exists. It's the reason Target exists. And there's some, to a certain extent, you should try to get that benefit from your provider as well. And then finally, see, I'm going to get you guys out of here for dinner soon. Finally, it's SLA. And you'll notice that we just put the word SLA up there, no nines. It's actually a funny story. We sent this slide into VMworld, and they sent it back to us because they didn't think this slide was done. Not joking. The SLA is not about the number of nines you could put behind the thing. Because I assure you that I can give you as many nines as you would like behind your SLA for cloud services, provided you give me as many pages of paper I need to write fine print about all the ways I'm going to get out of it. So the question is not what is the SLA and how many 11 nines or 12 nines or 13 nines or 2 nines of storage. The question I would say for your cloud provider is day one, when you're out there talking to them, ask them for their out-of-the-box generic SLA. Before they even know how big you are, what you're going to do, before any promises are made, just say, send me what you're willing to sign up for before I've told you anything about my application. And I assure you that will be the most indicative thing you will get from them about what it is. Because certainly the way we look at it and the way we promote that everyone should look at it is that the SLA is reflective of the spirit of the relationship. It should say all the things. It shouldn't just be, well, there's 9. What happens when your 5 nines of architecture goes down? Well, you get a credit in the bookstore. You can buy any book you'd like. Or do you get real company behind your money? Is the company going to put its money where its mouth is and stand up behind it? Because we firmly believe, and we believe that you should as well, that the SLA is not just a legal contractual agreement. It should be the spirit of what your provider is shooting for. That SLA should be designed not so that the provider gets out of only having to pay a few bucks when something goes down. That SLA should be designed that is the minimum acceptable standard you should accept from your provider, because they should be so comfortable that they're going to well exceed it, that's why they were willing to put it on paper. That's about it for us. Again, I'm going to let you go. So hopefully this has been educational. If anyone has any questions, I'm happy to answer them. The one thing I will say is that obviously we work for Terramark. We're a big cloud provider, and I would recommend, we're not actually at booth 110, but none of them have numbers, so it's irrelevant. We're the big red pillars down on the trade floor, but if anyone wants to come by, we have these shiny cards that have 15-digit codes on the back, which you can take home and go home and sign up for our cloud, and you punch in the code and you get $25 worth of free cloud. So if you just kind of want to see what it's like and feel with it and play with it a little bit before you have anything used, it's great for educational purposes. Take a stack of them, give them out to your staff, whatever it is, and you can go and use them, and we're happy to give them away, and I promise you won't even have to listen to too much garbage from a sales guy when you go to pick one up. So that's about it. Thank you very much for your time, and enjoy dinner.